All right, let's see. So, somebody have trouble with the door? So, sorry, which one?
F, 1F.
1F, okay. Oh, 1F. There we go. It's coming. There we go, okay. Yeah, okay. 1F. 1F. Sucks. So watch this. It's really a cool little thing you can do for yourself. Somebody remind me, sure, I'll say this in a weird way. Physically, what is an inverse trig function? Physically.
An angle.
An angle. Kick ass. That inverse trig function, do you know what angle it is?
No.
Nope. So watch what I can do for myself. This is an angle. Everybody with me? I don't even know what the hell that angle is. So I'm going to rewrite this like this. Do I have a formula for that situation?
The half angle formula.
Yeah, got a half angle formula. Does anyone remember it? If you don't, you got a day. You got 24 hours.
I haven't got it.
24 hours.
What a difference it is. 24 little times.
Is it plus or minus the square root of 1 minus cosine?
Blah, 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 blah. Okay. And real quick, can somebody remind me the arc cosine? Do you guys remember where it lives between?
0 to
0
pi.
to pi. I love it. And sine, what's the sine of sine from 0 to pi? 0 to pi, is it positive or negative? And from 0 to pi. 0
It's
to pi.
positive.
Positive. It's positive in first and second quadrant, right? So I know I'm going to pick the positive, because I know the angle I'm talking about is positive. Square root of 1 minus cosine theta over 2. Now what's really, 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 I don't know if you guys are going to be with me on this. I need to know cosine theta, correct? Let me see if you guys are cool. Well, there's a couple ways to look at this. I'm going to do this the long way. Can't I draw a triangle based on this part of it? Yes? No?
You like the hypotenuse over the,
Well, it's cosine, so it's, where's 5 go for cosine?
where does what go?
Where does 5 go for
Uh,
cosine? Cosine is what over what? Yeah, it's x over.
6.
Now, real quick, what angle, what do I actually want to know?
Cosine.
Cosine. Do I already know, do I have to figure out this side? What's cosine?
5 over 6.
5 over 6, and that's basically what this says. This tells me that the cosine of the angle is 5 over 6. And that's exactly what the formula needs for me. And then that one you just get get the top together, make it, one single fraction instead of one inside of another one. Maybe. So real quick, just to make sure you understand, if the question would have been instead, sine of inverse cosine of 5, 6, yes? I would have drawn this triangle, of course, and then the question is sine, wouldn't I need this side then? Okay, but I'm not asking for the sine of this angle. If I was, the answer would be 36 minus 1, it would be square root of 11 over 6. Is that cool? The answer to this question is square root of 11 over 6. This is asking for the sine of half of that angle. So then I use an identity, because I don't know what the half of the damn angle is. I know the cosine of the angle is 5/6. I don't know what half of the damn angle is. So I use an identity, and all it needs is cosine, and cosine I basically already know is 5/6. So just, let me see. Do you guys understand? If I say inverse secant of 11/4, that's an angle, correct?
Yes.
What's the secant of the angle?
11/4.
11/4. Bam! If I tell you that inverse tangent of x over x minus 2, what is the tangent of that angle?
X over x minus 2.
Bam! Okay. Maybe.
Oh. Yeah.
That's what that means, right? We kind of, that's what that means, because it's inverse. It's just, the answer is the angle whose tangent is this. So what's the tangent of the angle? Well, it's that. All right. So if I would have put a 2 there instead of a 1/2, sort of like that problem, I would use double angle formula, yeah. And for myself, you could be nice to yourself and say, that's an angle I don't know, let me call it theta. And then just write down whatever, now you got 3 options.
Oh, the 3 Pythagorean.
So real quick, I want to make sure everybody's with me on this. If this question would have been cosine of inverse cosecant of 3, how would you do this problem? What could I draw from this?
Cosecant angle would be 3.
Good, true. So whatever angle it is, the cosecant is 3.
3/1.
3/1, kick ass. Cosecant. Where's the 3, where's the 1?
That's the opposite of the sine.
Yeah, good. So hypotenuse is 3.
So it'd be like y.
Y is 1. Kick ass, because cosecant is based on sine. And then I can answer this question easy as shit, yes? What side do I need to answer cosine? X side. And what would that be?
Okay.
3 squared minus 1 squared. Is that all right? Just Pythagorean theorem, right? I know you guys can all do it, so I'm just going to do it.
I just couldn't think of what that thing was called.
No worries.
Yeah.
So this question is very straightforward, and then you can simplify this out, but that doesn't matter. That question is very straightforward. If it's a trig of an inverse trig, you draw the triangle, get the side you need, answer the question, next problem, Jeff, right? So what's worse about this problem than the 2's in the way? Damn you 2. Damn you 2. So then the first thing you do is you rewrite it using the double angle formula. So then you don't have. So real quick, what is the double angle formula for cosine? Give me one of them.
Cosine squared theta minus sine.
What is the angle on this side? What's the angle on this side? Not a big thing. If I say what's the sine of 11 degrees, what's the angle I'm talking about? Okay, so what's the angle I'm talking about over here? 2 theta. What's the angle I'm talking about over here? Theta. Do you see how, if the 2 is in my way, this gets it out of my way? Now these guys are talking about theta, right? So if I have cosine of twice, cosecant inverse of 3, that would become cosine squared of cosecant inverse 3 minus sine squared of cosecant inverse 3. And I can do each of these using a little triangle like we did before. I just made this look worse. Oh no, that's fine. Okay. Now I just asked you for one. Do you guys see? All right, this is the next level of this, is to realize there's an easier way to do this. Don't I have 2 things to do here? Aren't these both the same triangle, though? Because they're the same angle, yes? So it's not that bad, but if I did this instead, which is also another way to do cosine 2 theta, then I only have one piece to worry about. One piece. Okay. I love you guys so much. So again, the idea. So okay, let's do this. Here, you guys take a minute. Can everybody please, everybody do this problem right now. Do that problem right now. Do it. Let me catch up to you guys a little bit. What's the first thing anybody is doing? Tell me, what's the first thing you're doing?
Draw a triangle.
Draw a triangle.
Side is.
So which side is going to be 2?
It's gonna be the y.
It's a
And
sine, right?
Hypotenuse is gonna be 3.
Good. So in this case, I'm asking for the tangent of that, right?
For which you need to have the other stuff.
Good. Which is the square root of.
9 minus 4 would be 5.
Good. So then you can answer this question easy, right? What's this question? What's his answer?
It's 2 over rad 5.
Bang, right?
Yeah.
Does it really, would it matter if I would have said instead this question? Does any of this work change? Same triangle, correct? But now what's the cosine of this?
It's gonna be rad 5 over 3.
Bam! So when you see an inverse trig function, you can always draw a representative triangle. It's just it's not always useful. Here it's useful because now I'm asking a trig of that angle. If I draw the triangle, I can get the trig of that angle easy. Now, do you understand how any problem I give you like this needs to be relatively easy? You can draw the triangle, you can put the numbers on the right place, you can figure out the other side, and you can answer that question. That's all it takes for any of those kind of questions. Trig of, inverse trig of something. So what if instead the question would have been this? I can't do, because real quick, this is this angle, this is this angle. That's what lives in that triangle. That triangle leads to this. So this leads back to that triangle. Am I talking about that angle now? No, I'm talking about twice the, damn it. Why did Jeff, you jackass. Why did you put a 2 there? Jeff. But thankfully we have identities that I can rewrite it so the 2's not there anymore, right? In fact, if I do, so one identity is cosine squared theta minus sine squared theta. What's another one? For cosine 2 theta. Remember, cosine's an asshole, so one of them is where the cosine is first. 2 cosine squared theta minus 1, that's one way to do it. The other way is 1 minus 2 sine squared theta. So it's cosine's an asshole and makes sine go at the end. Didn't we already figure out the cosine of this angle? So now I'm saying 2 cosine squared of this angle minus 1. Well, we already know the cosine is square root of 5 over 3. So I need you to, if I rewrite using the identity 2 theta, I get this. So let me write this a little bit more explicitly. So now I'm talking about that. Isn't cosine acting directly on this now? There's no 2 in the way? Can't I do it as easily as we did that one? So then I can plug a root 5 over 3 in. And I get twice 5 is 10, bless you, over 9 minus 1 is 1/9. Crazy sauce. Crazy sauce. So the idea, so do you see how, this is basically how math works. If you understand this, all this is, damn it, that 2's in the way. Do I have a way to, I do have a way to make the 2 go away. Then I can do the same thing I wanted to do. If there was a 1/2, I would have used the half angle formula. Make the half go away. Then I can do it just like I wanted to, right? Does that make sense? It's sort of like if I have a 2 natural log of x plus, I want to get the 2 out of the way because then I can use the identity. How do I get the 2? Oh, good, the 2 just goes up. And then it's out of the way, and then I can use the identity, right? I need that stuff out of the way. Are you working today? Yes. About to pop out of there. Okay.
It's a lot to absorb.
Really? Yeah, again, I think I told you guys this in the early going. This is a 6-unit class, which is a lot. And pre-calc is definitely dense. I am never going to fault you for, this is not the easiest class. It takes a lot of time. It just does. Some of you guys in chemistry, some of you guys majoring in some science stuff, you're basically going to have to give up a little bit of your life now. Now, you want to find balance, dear God. You don't want to go insane. You can very easily go insane. You want to find balance. But you have to be like, okay, some of my social time's going to be gone. And I'm not saying any of you guys aren't already doing that. I know you are. So I understand. It's a lot. It's a lot. It really is. Anything else from the... Oh, yeah. So just reminding you guys today's review day. You can ask questions from the quizzes. You can ask questions from the practice test, from homework. General questions like, you know, do you have a way to remember this? What the hell was that?
Why did you square that red pi with 3?
Because the formula says it's squared. Right. So whatever cosine theta is, I want to square it. Square whatever cosine of this is. So I'm going to square rad 5 over 3, yeah.
Could you go over like graph for like quiz 6 for like the trace function? Like how would you graph them?
Number...
1 or 2? Oh, that's for the quiz though.
Oh.
For the past quiz, like quiz 6. Is that only test too?
Quiz...
6?
Yeah, I... The last problem here on the practice test, this one? This where you have to graph something?
Yeah, I guess, yeah.
Now, it could also be a secant or whatever, right? Okay, but... So I don't know, do you want to do a specific function? Maybe not necessarily tangent, but do you want to do tangent or?
Just any function.
Okay, because tangent is very different from secant and cosecant, yeah?
Right, okay.
So that's why I'm asking, you don't really, but, I mean, the way to find these things are basically always the same, yes? Somebody remind me what's the period of tangent before I do stuff to it? Pi. So don't forget, period for tangent is pi. So I'm trying to figure out the new period, I gotta start with pi. Sounds like a good idea in general. So what's the amplitude here? 3. The negative is gonna do what?
We're gonna flip it on the x-axis.
Flip it on the x-axis. I love it. I think yeah, this is good because I don't think I did the graph on the, I said I was gonna do it in class, so let's do it in class. Okay. 2. Alright, so let's gather all my stuff here. Amplitude is 3. What else can I get from this? Yeah, phase shift, what do I have to do? Now, listen. I think maybe the book shows this method, to be really honest. I don't look at the book that much, but
Period's gonna be one.
they have like B and C and they have these little things. That's fine. That's fine, because it's a valid method. But I always don't like that as much because it's not necessarily obvious why that works. That's why I try to show you, factor it, because then you can directly see, oh, it's just x minus 1 or something, and we know what that does. Instead of just this, we'll take whatever c is and divide it by b. Oh, that's just magic. You don't know why that works. But, again, it's a valid way to do it. Can anyone help me out if I take a pi out? What is left here?
It's gonna be x minus 1/4.
Yeah, just the pi goes away. Sounds sad. What's the phase shift then? Right 1/4. I love it. What's the new period?
1.
Yeah, it's the old period divided by k. So we get 1. Now don't ask for this because I don't want to like take points off and force you to if you don't want to do it. But what's the step size?
It's gonna be pi over 4.
No. What's the new period? 1. So it's the new period cut in fourths.
Oh.
It's always whatever period you're working with, chopped into 4 steps.
Okay.
And then me, I'm going to do the beginning work. So it begins at negative pi over 2 because it's tangent. Normally it does. Do you see how I can kill all the pi's? So things look a little less busy. And then if I add 1/4 over, 2/4 minus, 1/4 minus 2/4 is negative 1/4. You guys semi with me? I highly recommend, especially with tangent, because it doesn't start at 0 normally. So where you begin is not going to be obvious. Look at this. What's the phase shift? Right 1/4. But where do I start? Negative 1/4. Now, why does that make sense? Because tangent normally starts negative pi over 2. It starts back already. So it's not the easiest thing in the world to kind of like tease out where you're going to start. So why not just do the work that's going to just show you where to start? So take a minute. Can you guys do as much as you can to graph this? And then we'll do it together. Try to graph, using what we know. Try to graph that thing. Be really, really careful about the negative, correct? What does tangent normally look like? Yeah. What's it going to look like now? Just rotate my track. Let's just do that. Yeah. It's going to look like cotangent now because it's been flipped because of the negative, correct? Okay. Bye-bye. Okay, let's see. So I'm going to start at negative 1/4. I'm going to step by 1/4. Well, that's bodacious. Bless you. So I don't have to worry about LCD because it's already LCD, right? So I'm going to start at negative 1/4. One step will take me to 0. Another step 1/4. Another step 2/4. Another step 3/4. That's 1, 2, 3, 4 steps, baby. Okay. That's creepy, Jeff. That's too bad. So I know I'm going to hit 3 and negative 3 at some key places. What's at the ends here?
Asymptote at like minus 1/4, I think.
Good. And then another one on the other side.
Minus at 3/4.
I love it. The tangent would normally go from here up, but now I'm multiplying by a negative, so now I'm going to start up here. So at 0, so the first step in is where it hits the quote amplitude.
Yeah,
Where does it go at the next step?
1/4.
1/4, like here? 0, okay. Next step,
We have negative 3.
yeah, so it starts off at the asymptote, hits the quote amplitude, then it hits the 0, then it hits the negative of the amplitude in this case, and then it goes to the asymptote. That, and again, I don't know if you guys really get this. That is what finding the step size is all about. I know at every step, every 1/4 of the way through, it's going to hit the next kind of major thing. Tangent, asymptote, amplitude, 0, amplitude, asymptote. That's why we do that, just to make this step easy. How can I check this? Check yourself. I'm inquiring as to how I might check myself.
Well, let's see, you can start with that's minus. And you
So let's look.
put it back upside
An
down.
input of 1/4 should give me an output of what, according to my graph?
Okay.
0. So if I throw a 1/4 in here, what's pi times a fourth? Pi over 4 minus pi over 4 is 0. What's tangent is 0? 0. So what do you think in your head? What do you think in your head when I say what's tangent of 0? Is anybody, some of you guys are sitting there going, I think that I'll wait till you say it. No. Tangent of 0. What do you think in your head when I
I'm
say?
thinking 0 over 1. Which would be
Well, why? Why do you say 0 over 1? Because what are you really thinking when I say tangent of 0? You think sine of 0 over cosine 0.
Cosine.
Then you go, okay, sine 0 is 0, cosine 0 is 1, 0 over 1, 0. Some of you guys might have tangent memorized. I don't know. I don't. But you can. Nothing wrong with that. Holy shit.
0.
So some of you guys might just memorize the tangent of 0 is 0. I don't know if anybody's done that. If you've done neither of those things, that's bad. That's bad, okay? You gotta do something. You gotta either memorize it correctly or figure out how to answer that question. Right? Is that okay? So the only nice thing, well, I mean, I won't say that because I love all this shit, so I'm not gonna say that. One of the better things about this is that no matter if it's tangent, secant, whatever, I'm basically finding the same stuff. Amplitude or just amplitude, phase shift here. I'm finding them the same way. So yes, the end result looks different, but the work is very similar no matter what the trig function is. Right? That is one nice thing. Okay. That hurts a bit. Number 4? Okay. So oh yeah, I'm sorry. So remember this will be a bonus on this one, and then there'll be a problem on the next test. Right? That's from section 9.5. Bonus on this test, actually on the next test. Okay. So if you don't want to do any section 9.5 homework yet, I understand. Just focus on getting up through 9.3 because 9.4 is extra credit. 9.5 is not extra credit. 9.5, I'll put a bonus on here just in case somebody actually tries some of that out, and it'll be on the next class. We just didn't have the time. I'm trying to be nice again. You guys are like, you're mostly failing, Jeff, but that's good you're trying.
So that's gonna be from 8.3 to 9.3.
8.3 to 9, no, 8.2 to 9.3. Because the last test went up to 8.1. Yeah. So it could be a tangent or a cosecant question.
I was just gonna say, so we only have to turn in homework up to 9:30.
That's right. Yep. You can turn in 9.4 if you want to try the extra credit. You can turn in 9.5 if you want to do that and get it done. Right? But you only are responsible to 9.3 for tomorrow. Like some students are like, I don't think you know what the word only means. So it's wide open. Anything you guys want to talk about? From the quizzes, from the tests, from the practice tests? From the test. Say again? QA, please. QA. Yeah, look at this thing. So yeah, it did. Does anything immediately jump out at you on either side that you can try to do? Any identities you immediately see? Any identities? There has to be. There must be. Say again?
I said the double one.
Yeah, you got two double angle formulas right there, right? Now, can somebody tell me what sucks about the cosine one? 3 options. And most of the time, only one of the options will get you where you need to be. But sine 2x kicks ass. It's only got one possibility, correct? Okay. If you rewrote, now, do you guys understand that? I want you to understand this. Whenever I see cosine 2x, I'm not going to rewrite it yet. I'm actually going to focus on the other side because that'll give me a hint. You guys got it with me? That'll give me a hint how to rewrite cosine 2x because there's 3 ways to do it. It sucks. Stupid little cosine. So on the left-hand side, I can rewrite sine 2x, correct? Because that's only got one option. So I know that's... And also, what angle is on the left-hand side? What angle are they worried about on the left-hand side? What's the angle on the left-hand side? What's the angle that the trig functions are working with? I love you guys so much. Like on part C, the angle is A, right?
It's X.
So on the left-hand side of part A, what's the angle they're working with? 2x, thank you. On the right-hand side, what's the angle they're working with? X. That's another giveaway that I need to rewrite the double angle in terms of just x, because there's no way in hell the two sides could be equal if one of them's talking about 2x and the other one's talking about x. I can't ever show that's equal. So, on the left-hand side, I would do this. What's sine 2x? Now, so most of the work is going to take place on the right-hand side because I don't know yet which option for this is the right one. But I'm going to write this just so if I see it, that'll tell me some good shit, right? Can somebody help me on this side? What are the only trig functions involved? Yeah, cos and sin. I love it. Cosine and sine. So what's one thing I could immediately do on this side to make it look more like that side? Why does this side not look like that side? There's actually several answers I would take. Why does the right-hand side not look like the left-hand side? Yeah, it's got secant and cosecant. It's also got how many terms?
2.
2 terms, and the other side only has 1, okay?
And it's got fractions.
And it's got fractions. But if you do like Philip said, what is 1 over secant? How can I rewrite this?
Cosine.
2 sine x. So what do I end up with if I bring all these up? How many of them? 3. Can you do the same thing on this guy? If I bring all these up, what do I end up with on top? If I flip them, right? You guys, is anybody with me? I've got, so, anytime I see 1 over secant x, that's cosine x, because that's the reciprocal of cosine. So 1 over secant x is cosine x again, right? Do you guys see what I'm saying?
Sine
What's up?
cube x?
Did you say that we can't do things to both sides?
I definitely didn't. I haven't done a damn thing to both sides. I am doing something on each side. I can simplify each side. I am not allowed to add something to both sides, subtract, multiply, divide, and I have not done that. I can all day long simplify each side. So every step I'm taking, I haven't changed that side at all. It still has the same value, it just looks different.
Is there a sine cube x missing on the right side?
Yeah, because I haven't finished writing it yet, because that was my last question that hasn't been answered yet.
Okay.
So when I flip this up,
Gonna be sine cube x.
okay, sine cubed x. Can you already see how the two sides look a little more like? Do you see a 2 sine x cosine x?
Yeah.
So you ready? Isn't on this side, isn't the 2 sine x cosine x multiplying by stuff? And I've got 2 terms over here, correct? Can anyone see what a good next step would be then? Why is that never a good idea?
Well, you can't do that because you don't know that they're equal yet.
Good. I don't know they're equal. I'm not allowed to do stuff to both sides. Now, instead of dividing by 2 sine x cosine x, I can just take it out. So oh, you're good. Wait, are you good? All right, let me try this again. And I understand this is so weird. You're not used to this. Do you see how this side is 2 sine x cosine x times something? Yes.
Yeah.
So the way to make the sides look the same is if I can write this as 2 sine x cosine x times something. And of course the way I do that is I just take a 2 sine x cosine x out. If I take 2 sine x cosine x out, what's left here?
There's gonna be cosine squared x?
Yeah. 2 is out, sine is out, 1 cosine is gone, so I have 2 cosines left. What about here? I take a 2 out, I take a cosine out, I take 1 sine out.
2 sine x.
Okay, I took a 2 out. Sine squared x. And what is cosine squared x minus sine squared x?
1?
No. Cosine squared x plus sine squared x is 1. What's cosine squared minus sine squared? Yeah.
Oh.
Is that the same thing I have over here? Check. So what's weird is, do you see how I used one side to help me figure out the next thing to do on the other side? That is one thing identities have going for it, is you have a target. Each side gives you a target for the other side. So I'm like, 2 sine x cosine x is out by itself. Oh, let me take a 2 sine x cosine x out, and then I can look at this shit that I got left and hope to God it becomes this thing. And in this case, it did. Yay. So you're not completely floundering around by yourself. You can use the other side as a hint. Do as much to one side as you can, and if you're like, I don't know what else to do, start working with the other side. If one side has fractions and the other side doesn't, combine the fractions. Maybe something's going to cancel, right? I'm using the one side to help me figure out what to do with the other side. Okay.
So what's cosine squared x minus sine squared x? What is it?
Well, we pretty much gave the game away there, but that's cosine 2x. Right? That's the first identity for cosine 2x. So by tomorrow, you need to know all your double angle, half angle identities. Sine 2x kicks ass, yes.
Gotta
Sine's the
sharpen
nice
that
guy.
spoon.
Sine 2x is easy, yeah? What's sine 2x? We already did it, it's okay. 2 sine x cosine, that's awesome. Cosine 2x sucks a little bit. But what I do, I think this semester, I actually have memorized this now. I've never had this memorized before, but I feel like I've got it memorized now. And I feel kind of silly that I didn't notice something, but I never had it memorized. I always start here. So cosine 2x is this. This is what I have memorized. Then cosine squared is 1 minus sine squared. There's already a minus sine squared, so it's also 1 minus 2 sine squared. Sine squared is 1 minus cosine squared, so it's also 2 cosine squared x minus 1. But look how cosine is still an asshole. Me first, me first. You could be lastly and be negative sine, right? So that's another cosine is an asshole thing. But I would remember this. This is what I did as a student. I remembered this, and I just built these two as I needed them. But you can remember all three if you want to. Just don't memorize 0 of them, because that's not good. Yeah.
Is there multiple ways to get to the answer?
Oh, it could be, totally. Yeah. I should do it. Oh, you kept going, yeah, beautiful, cool. So if you happen to pick the right one, then yeah, good. I love it. So the way I did that identity was I worked primarily on the right-hand side. Jacob worked primarily on the left-hand side and got it. Yeah. There's so many ways to make them meet the two sides.
Can you go over 3B, please?
Yeah, all right. So I explicitly say you have to use a half angle identity. So the first thing you do, can you rewrite this in the form cosine of half something? Because that's the half angle identity, right? So cosine of 165 is cosine of 1/2 of what? What is 165 half of? Well, how do you figure that out?
330?
Yeah, you double the damn thing. So 330. Is 330 an angle we know some shit about? Because what's the reference angle for 330?
30 degrees.
30. So we know shit about it. Much better than 165, which we know nothing about. So now you just have to remember the half angle formula, right? So if you want to, here's one thing you could do. The question is the cosine of 1/2 of 330, right? But if you want to, just write cosine of 1/2 theta, and then write down what you have memorized. Now, real quick, 165 is in which quadrant?
Second.
And what's true about cosine there?
It's negative,
So I'm going to pick the negative option, and then what's the rest of the...
plus or minus.
No, I'm going to pick the negative option. Not a plus or minus. I'm going to pick the negative option because I know it's negative, right? I know cosine of this has to be negative because I'm in the second quadrant. So I pick the negative. What goes inside?
1 minus cosine theta,
1 plus, because cosine keeps the plus for itself because it's an asshole.
and then over 2.
Good. And now you just plug in what is theta?
Uh,
What is theta?
165.
Baby. Nope. Theta is 330. Yes?
Oh,
Theta is 330. Theta is the thing that we're taking 1/2 of to make 165.
right, okay.
Good. So the whole point of this identity is to rewrite a cosine question you have no idea about the angle in terms of when you do. So now this piece you can just work out. Work it out. Is the answer to this going to be positive or negative? What quadrant is 330 in? Fourth quadrant, is cosine positive or negative there?
Positive.
positive, because x is positive over there. Sine's negative, but cosine's positive. So now it's gonna be positive, and then you just gotta remember what the cosine of 30 degrees is.
Wouldn't it be negative though, because there's a negative on the outside of the square root?
That's negative all day long.
Okay.
That it says cosine of 30, which I know is positive. Do you see what I'm saying?
Yeah.
That's been determined. You know the answer is gonna be negative. The inside, you just do exactly what it is. Cool.
Brad, 3/2?
Yes. So here, I'm gonna go ahead and give you the answer key a little early, just so you have some time to look it over. If you have not tried to practice this out, don't even look at this damn thing, because it's not gonna do you any good. It'll just do bad.
Yeah. Either thing.
So one bad thing about this here rooms. So you can see on number 4, I indicated that's extra credit on this test. It's going to be on the next test officially. Here. Yeah. The next test is test 5, and then we have one more test. We're crazy. So I normally do like one test per unit. So in my 3-unit classes, we have 3 tests. In my 6-unit class, we have 6 tests. Which is kind of nice, because then each test is worth a little bit less than it normally would be, like half as much. So one single test can't hurt you as much, but they can kind of group up on you, sort of like the quizzes. Yeah. That's not back out.
I know it's on the syllabus. What percentage is?
Say again?
What percentage of the grade?
I think I said 50 or 55% total for the test average.
I mean, quizzes or what?
20 or 25%. Well, the quizzes and homework together is 20 and 25%. 20 or 25%. Finals 20 or 25%. If I remember correctly. 25 or 30? I can't. No, really. I'm trying to go off the top of my head here. But
That's a big percentage. I could get that if you
some people make it a lot more. So when you go into the final, you will have about 75% of your grade set. So I understand that 25% sounds like a big, but it's 1/3 as much as you're going to go in with already set. So that's good and bad. If you're doing well, a final can't like drag you down all the way, right? But if you're not doing well, a final can't lift you up all the way either. But it's a decent chunk of the grade, so you can lift yourself up out of failing. If you're currently failing with the final, you can certainly pull yourself down, but it's not going to affect you as much as it sounds like, because you're going to have like 75% of your grade set going in. No idea how that made you feel, but that's just the reality.
change the letter grade.
Yes, it could. Don't forget, remember this, this is a small thing, but it does make a difference. Remember I've got that variable percentage? So whatever is your lowest between tests, homework and quizzes, final, whichever of those is your lowest grade, I'll count for the lower percentage. You guys kind of with me? You guys all forgot? Okay. So on the syllabus, it says, for example, the tests are worth 50 or 55% of your grade. So if the test average is the lowest grade amongst the three groups, test average, quiz homework average, final, I'll count the test for 50% instead of 55. So they will hurt you less. And the times that I've analyzed it, there's always been like 1 or 2 students who would have failed if I didn't do that, right?
We can do corrections on everything but tests, right?
No, you can correct tests too, yeah, of course. Yeah, the only thing you can't correct is the appropriate leading final. So if you've never made corrections to quiz 1, can you still turn it in? Yes, you can still turn it in on the day of the final. You're not gonna get anywhere near as back many points as you could have, but if you get enough of them right, you'll get something back. And every little bit helps. Plus, just doing the corrections is a form of studying. There's a method to my madness. So, doing that's gonna get you ready. So even if you did it earnestly, and you didn't get any points back, you still got more practice with it. You should do a little bit better on the final than you would have. But you know, get some help so you get some points back. That's always a good idea. So what's your priority going forward would be, I would do test corrections. Any test corrections you haven't done, immediate priority. They're a great way to study for the final. You're an immediate boost to your grade, correct? Then my next priority would be quiz corrections. My next priority would be any homework I haven't done yet, and the next priority after that would be like any homework corrections I still have to do. Somewhere in there would be, so I'm talking about getting close to the final now. I'm gonna give you a practice final, all that kind of stuff, right? There's practice final with an answer key out. Okay. Let's not worry about the final right now. Let's focus on test final. Anything else from the practice test or the quiz? Any of my work look wrong on the key? I'm only human. I definitely make mistakes. I'll show you guys something real quick before I forget. I almost forgot. Can you guys see that all right? I just want to show you this real quick. It's not necessarily going to help us do much of anything. Can you guys see this? So real quick, we know this. The sine is the y side, yes? And the cosine is the x side of that triangle, yes? The things that you haven't seen yet are where the other trig functions are. So the tangent is here. Tangent squared plus 1 equals secant squared. So this is a right triangle here. Tangent squared plus 1 equals secant squared. That is one of the Pythagorean identities. Do you guys see that? I like it. And then up here is a triangle that does the same kind of thing. There's cotangent. Now, remember, somebody tell me, what is at pi over 2 for tangent? In between negative pi over 2 to pi over 2, what's at those for tangent? Asymptote. Which means as I approach 90 degrees, tangent should go to infinity. So watch this. Let me make this go slow. Go slow. Okay, it's going to move at some point. I might have made it go too slow. When are you going to move? There, you're going to move very soon. There it goes. All right, see tangent getting bigger? As I approach 90 degrees, see cotangent getting smaller? Tangent gets stupid big. Look how big tangent is. Oh, man. Yeah. Right, tangent is stupid big. And then, of course, when I'm right at 90 degrees, tangent is actually infinite. So the length of tangent depends on where it hits the x-axis. What happens at 90 degrees? Tangent would be straight across. It would never hit the x. So how long would it be? Infinitely long. I don't know if you guys are really with me. Okay. So again, you can see the sine is starting to shrink again. The cosine's getting bigger as I approach the x-axis. Tangent's getting smaller. Tangent's going to be 0 at pi. I almost had it. I know there's a way you can do this, but I always forget what it is. No, that's too big of a jump. It's okay, Jeff. You'll be fine. I'm not really a YouTuber. There we go. Tangent 0, but cotangent is infinite. It's just going up forever. All right, I'll stop doing that. I just thought maybe you guys... We knew this. Again, we knew the sine is the y piece, cosine is the x piece. What we didn't know was, is tangent somewhere in here? Yes, it is. Is secant? Yes. What about cosecant? Yes. All right, I'll stop. What was this one, Jeff? Oh yeah, this one is just this. Let me see. Let me reset it. Let's do this. Here's sine and cosine. So as I go around the unit circle, there's the y piece getting bigger and smaller. There's the x piece getting bigger and smaller, going negative. Not too amazing, but it's kind of nice to see it kind of drawn out. If I do tangent, this is tangent. This piece here. There it goes to infinity, and here it comes from negative infinity back up. Again, it's kind of nice to see how these fit in. Doesn't really help you with any specific problem, but still. Good job, Jeff. Thanks for helping us. Okay. All right, that's enough. Sorry. So, anything else you want to talk about? Hopefully it's not copyrighted. I'm probably going to get a strike. We'll see what happens. You can't monetize that.
Can you do 2 seats, 1 parenthesis?
All right, so does anyone see anything? Be really careful about this side. Why is this not cosine double angle? Say again?
That's 2B, you said 2B.
Oh, you said 2C, sorry. I got so excited. Oh, 2C, okay. This one's funky. This one is funky. This one's a little bit of a bonus kind of push. If you see this in an algebra problem, what do? Can I cancel an x?
You gotta take out the X.
Can I cancel an x?
Not yet.
I won't ever be able to cancel an x. Because x is not a factor. Division is not the opposite of subtraction, so I can never cancel part of a subtraction with division. So what do I do instead? What can I do at the bottom?
Factor.
Factor. Yeah, now it cancels. What cancels? X minus y. Good. So so what's the answer? What's wrong if I put this?
1 over x plus.
Yeah, it's on the bottom. Yeah, okay, I love it. So, looking back at this, what do I do?
Factor those two.
Factor at the bottom. So we get tan A minus cotangent A on top. How do I factor the bottom? It's not that bad. Tan squared, so it's going to be tan
Minus.
cotangent squared, cotan
Plus.
plus, and then
Factor out.
die. So far I got this. Let me write this a little better. Because I think my key got a little bit smushed for room. So far I am here.
Sine, cosine.
And I'm trying to make it look like this. So yeah, a good idea, let's see. If I rewrite this in terms of sine and cosine, what would this one be? Now, side note, if I had 1 over pi over 7, everybody in here should be like, okay, that's easy as shit. What is 1 divided by pi over 7? 7 over pi. So if only the bottom is a single fraction, I just have to flip it because it's under 1. So how do I make this a single fraction? Say what now? I can't flip it because there's a plus sign in the middle. Flipping the bottom would just be 1 over it, which is no good, which is just exactly what this is. So if I combine these two, then I could flip the resultant fraction. If I can make the bottom a single fraction, I could just do this. So what's this first guy need? This second guy has. This first guy.
It needs
He needs a
a
sign.
sine A in the.
So if I multiply top and bottom by sine A, what's the second guy need?
Cosine
Cosine A. So if I multiply top and bottom by cosine A, so you get a cosine A. So I'm going to get 1 over sine squared A plus cosine squared A. Well, that's 1 over cosine A sine A, right? And what is 1 over cosine A sine A? That's right. Which is what I wanted. Sorry? So that's exactly what I wanted, yes.
Clarify, with these problems, we're just working on one side at a time, and we can't switch.
Of course you can work on both sides.
No,
I've
but
done
I'm
that
saying
several
you
times.
can't divide by. on
Yeah, you
one.
can't do something to both sides. You can work on each side separately, yes.
That makes it easier.
Okay. It doesn't, but okay. Is that all right? Now listen, again, the first thing we did now might be a little more obvious, so you should kind of look for if I can factor something. You get here and you realize this side's only got sine and cosine, so I'm going to rewrite everything in terms of sine and cosine. Then I've got fractions inside of a holy shit, if I get the bottoms together, then I can flip what I get. So every step, you find what makes sense to try to do next. Sometimes you're looking at the other side. The other side only had sines and cosines. Let me write this side with sines and cosines. Or you're just, is there an identity or is there an algebraic thing I could do? Right? I can't give you a ton of these because you could be very unlucky and just try a lot of stuff that doesn't work. So you got to keep trying something else. That I understand. But I can't give you a ton of these because I could take you a long time. Yeah.
On the test, I know what be true or
Oh yeah, whenever I say verify the identities, I'm kind of giving you a hint that it should come out true, but that doesn't mean you can assume it's true and do something about it. Yeah, in the homework they do say, well, the instruction should say, show that it's true or not. Yeah, okay. Those are evil. Those are way evil. Because you're just like, I don't know if I did a mistake or if it really isn't equal yet. Right. All right, so anything, oh gosh. Here we go. Oh. Anything else, guys? This one go okay? And this one here? Maybe so. Okay. Yeah.
Can we do that?
Oh, okay. part B. Is this a double angle thing? Why not? Angles are different. That sucks. So do you guys see how there's really nothing I could do on this side? This side is the one, and this side has a ton of stuff I could do. What's the immediate first thing I could do? There's no distribution there. There isn't. Because it's not cosine times x plus y, for example. It's cosine of x plus y. But what is that? It's an identity. It's the sum for cosine identity. What's cosine of x plus y? It's cosine
A plus B times
cosine x
plus
cosine y
Minus
minus
sine of x times y.
sine x y. Okay. And then you just do the same thing for this guy, right? But it's got a minus in the middle, so it's going to be different. It's going to have a plus there. Right? So then you're going to have no factor. You're going to do the exact opposite of that.
An opposite angle, we multiply it out.
Yeah, you're going to FOIL that bad boy out. Yeah. FOIL it out. That's the first step. Right? And how did I know to do that? Well, just because. There's not the damn thing I can do the right hand side. And the left hand side is identities. They're just immediate, obvious identities. So the nice thing with that is, you almost can't, it's almost impossible for you to be doing the wrong thing, because that's the only thing you can do. Now after this, there's some options. You FOIL it out, see what happens. What's nice about when you FOIL it out? What's almost the only nice thing about it? What happens to the middle terms?
they disappear.
They cancel, because it's all the same terms minus plus. But, you know, that only comforts you so much. I will say this one is not as obvious about what to do, so I don't know if you're looking at the key. There's a bit of a choice you have to make. There it is. Yeah. When you multiply things out, you're going to get some squares. And in general, so one thing you could think about on the right-hand side is their squared stuff. So you could think maybe a Pythagorean identity is going to help me, but the fact that they have different angles, they could never kind of go together anyway. So I just sort of leave it alone. But once I FOIL this side out, I'm going to get some squared stuff. So then again, I think, okay, maybe the Pythagorean identity is going to help me. So I give you a verification problem. You look for an immediate identity. Is there a cosine x plus y? Is there a cosine of 2 theta? Is there whatever? You look for that. Rewrite it. See what it does for you. Second thing, is there anything algebraic? Can I factor something? Can I multiply something out? Can I combine two fractions? Third thing you look for is, are there any squared trig functions that might relate to a Pythagorean identity? Maybe if I replace it, it'll cancel with something. It'll reduce. So when you're staring at an identity, you're not just waiting for inspiration. You're like actively looking for these things.
So the first thing is what?
Oh. Immediately obvious trig identities. Like on this one, I saw cosine of x plus y. Okay, those are two identities. Let me rewrite them, because that's really the only thing I can do. Or if I saw sine of 2x, identity. Next thing is there anything algebraic I could do? Can I combine two fractions because one side has fractions and the other one doesn't? Can I factor? Can I FOIL? Can I multiply? Right? And then the next thing is, do I see any squared trig functions? Because that might relate to a Pythagorean identity that I can use. And then your last resort is always just rewrite everything in terms of sine and cosine. It's kind of like, if you feel like I really have no idea, just try to rewrite everything in terms of sine and cosine and see if anything cancels or comes together. Getting away from identities for a second. What was tricky about this one? There's something tricky up here. It's tricky. Don't cosine and inverse cosine want to do what? They want to
Kill each other.
kill each other. But the answer is not 4, 5, or 3. Why not? Because, Jeff, math is evil. No. What's the output for inverse cosine? Where it can live between 0 to pi, 11. Cosine of 4 pi over 3, whatever the hell it is, what sign does it have? Cosine of 4 pi 3, is it positive or negative? Negative, that's right. So the inverse cosine has to be an angle where cosine is negative, it has the same value, and it's in the second quadrant, because that's where it's going to be negative, correct? So what angle has the same output for cosine as 4 pi over 3, but it's in the second quadrant? Well, I mean, that's a weird way to say it. It's true, but it's not.
150?
2 pi over 3. That's all. Isn't the reference angle for that pi over 3? So I need you to understand. Cosine of 2 pi over 3, cosine of 4 pi over 3, they have the exact same output, correct? Because they both have a reference angle of pi over 3. They're both where it's negative. Inverse cosine can only have answers between 0 and pi. So there's no way in hell the answer could be 4 pi over 3. It's got to be the other angle that would make cosine do the same thing, 2 pi over 3. Thanks, Jeff.
You go, Jeff.
The way it works. Huh?
You go, Jeff.
No. That, again, it is important that you understand the output of inverse sine and the output of inverse cosine. And this is a very deceptively easy problem. It's still easy. It's just got that one little thing you gotta be careful about. The answer cannot be 4 pi over 3 because that's outside the realm of what inverse cosine can give you. Part A and B should be gimmies. You want to look for those. What can I do for part A and B? What's the first step on both?
Angle.
Draw a
Triangle.
triangle. Yeah, draw a triangle. And then you can answer whatever trig function I got sitting out front. Yeah. I know part B has an X in it. Who cares? You just put it where it goes and you figure out the other side. Okay, all right. So right now, if you're really behind in homework, your priority is to do some out of every section up to 9-3. Let go of doing every single problem. Some of you guys are like, I'm way ahead of you, Jeff. Cool. You have got to come in with practice under your belt from all the sections. All right, guys. My excited students. Let me know if you have any questions. Otherwise, I guess it seems like we're done. If you still have questions, let me know. It's not right over, but
We're gonna come tomorrow.
you better understand, huh?
You.
Me? That's my plan. Thank you. Unless I get sick or something. Let's see. Well, So real quick, this one, to make cosine come out small, it's gotta be far away from the x-axis, so it should be pi over 3. It's pi over 6 would make cosine rad 3 over 2, right? Does that make sense? So you're always thinking backwards, what angle would make sine do this? I like it. Yeah, okay, good. And then secant, yeah, this looks familiar. Yeah, so you can set up the sides, I love it, and then this one you already showed me, yeah, looks good.
So I forgot to say on here that I put these like